All right, so we need to put the original information into a matrix, right? And the data that's given to us is in a 3 by 4 matrix. Whoops, not 34 by 1, a 3 All right, so we put in our data here, and we have 1, 4, 2, 5, 2, 10, 1, 7, and 7, 5, 7, 1. All right, so then we just go to our stats, go over to tests, it's easier to go up to the chi-square test. All right, this is fine. All right, so our p-value is 0.0136. All right, that is to 3 sig figs. Remember, zeros at the beginning do not count. All right, C. State, giving a reason, whether the null hypothesis should be accepted. All right, since the p-value of 0.0136 is less than the significance level of 0.05, of course, from the 5%, right, we reject the null hypothesis. All right, and that's all it asked, right? It didn't ask, to kind of say anything within the context of the problem. It literally just said, are we accepting or not? Are we accepting or rejecting the null hypothesis? In this case, we are rejecting. And that is it for number 4. Number 5. Saucer works for a conservation charity who rescue orphaned orangutans. Over many years, she records the weight and kilograms of the orangutans when they first arrive. The data is illustrated in the following box and whisker diagram. Of course, refer to the actual test for the diagram. All right, write down the median weight of the orangutans. All right, so of course the median is the bar that's in the inside of the box, not necessarily the middle, but inside the box somewhere, and that is at 1.65. So 1.65 kilograms. All right, B. Write down the lower quartile. All right, the lower quartile is, of course, the left edge of the box, and in this case, that is 1.5 kilograms. All right, C, find the interquartile range. Of course, the interquartile range is equal to Q3 minus Q1. All right, we just found Q1, but we did not find Q3. Q3 is 1.75. So 1.75 minus 1.5, our Q1 that we found in the last problem. All right, so that's equal to 0.25. All right, and D, show that the data does not contain any outliers. All right, so outliers have to be more than 1.5 times the interquartile range away from the nearest quartile. All right, so we're going to say 1.5 times the IQR, all right, which is 0.25, All right, and that equals 0.375. All right, so now Q1 minus 0.375 is equal to 1.5 minus 0.375. All right, so that is 1.121, 1.125 rather, sorry. All right, and to be more than 1.5 of the IQR outside of it on the high end, that would be Q3 plus 0.375. All right, so 1.75 plus 0.375, and that is 2.125. All right, so we would have to have data outside of this, right? Either lower than 1.125 or higher than 2.125, right? And we don't, right? Since the minimum is greater than 1.125 and maximum is less than 2.125. All right, there are no outliers. And we're done with number 5. Number 6. Dr. Scott Pop is investigating the population of otters in Scotland. The doctor found, based on historical data, that the population of otters, P, could be modeled by P is equal to 7,500 plus A times 1.09 to the T power. So we know that P is equal to 7,500 plus A times 1.09 to the T power. Right, where A is a constant and T is the number of years since the start of the year 2000, where T is greater than or equal to 0. At the start of the year 2000, the population of otters in Scotland was 8,000. Find the value of the constant A. So all I do is plug 8,000 in for P. All right, so 8,000 is equal to 7,500 plus A times 1.09 to the T power. Sorry, it said in 2000, so I know T is 0. Whoa. Anything to the 0th power is 1, right? And A times 1 is just 1. So subtract 7,500 here, and we should know that 500 is equal to A. Part B. Find the population of otters in Scotland at the start of the year 2020. All right, so now I know P is equal to 7,500 plus my A we now know is 500 times 1.09 to the T power, which is the number of years after 2020. I'm sorry, after 2000. So 2020 is T equals 20. All right, you plug that into your calculator. I won't bore you with plugging that straight into your calculator. All right, but we get 10,302.20538. All right, so if you wanted to do this to 3 sig figs, 10,300. And our last part, C. Dr. Scott Pop estimates the peat population of otters Scotland can sustain is 15,500. Work out the year in which Dr. Scott Pop expects the population of otters to peak. All right, so we set our P equal to 15,500. And here we're just trying to solve for t. Again, I would just use solver here. Makes life very easy. So t is equal to 32.1729. All right. So, 2032, usually they have you round up here, right? Like because you're more than 32 full years after. So 2032 or 2033. I would go with 2033. Of course, you know, I'm not sure if IB does it the same way that everywhere in the United States does. The United States would say this is 2033. IB may say this. So you may just kind of want to explain your rationale, whichever way that you answer. Like if you say 2033, say if you're more than 32 full years over, you have to be into that 33rd year. If you explain it, they should give it to you. All right. 7. The perimeter of a rectangle P whose width is double its height can be represented by the function P of A is equal to 6 times the square root of A over 2, where A is greater than or equal to 0. A is the area of the rectangle, and the graph of the function P is shown for A for A between 0 and 32. Okay. A. Write down the value of P sub 32. All right, so P sub 32, right? You literally just say 6 times the square root of 32 over 2, right? That's 16. The square root of 16 is 4. 6 times 4 is 24. Of course, you can just plug that straight into your calculator. All right, it says the range of P of A is P of A is between 0 and n, right? So hence, write down the value of n. All right. So this one's a little bit odd. All right. We basically just found the highest point, right? If you actually look at the graph, you can see that this graph is strictly increasing. And since the domain of this graph goes from 0 to 32, right, then the max value, right, the highest y value that this thing occurs is what we just found. It's a lot easier to see on the graph, so do refer to the graph for this. All right, C. On the axes above, draw the graph of the inverse function p of -1. All right. What I, of course, recommend you do there, all right, is that you take some points that are on the graph and flip them around. All right. So, for instance, one of the points, we know that on P, we have the point 3224, right? This would tell us that the point 3224 has to be on my graph. Well, that means for my inverse, I know that I have to have the point 2432, right? I just switch those around. And you can do that for a couple of other ones. Another nice point that they have on here is looks like 1416, right? So it looks like they have 1416. Again, refer to the graph, which means we have to have the point 1614, right? Since I don't have the axis and everything on here, all right, the original graph, all right, looks something like this. Although, of course, there's no arrow because it cuts off. All right, so the inverse will look something like this. All right, of course, with this being 2432. All right. And this being 1614. Okay. D. In the context of the question, explain the meaning of P inverse of 12 equals 8. Okay. So P inverse of 12 equals 8. All right. So my original function, all right, you plug in an area and you're given the perimeter. So here you plug in the perimeter and you're given the area. All right. So that literally means when the perimeter is 12, the area is 8. Right? It's just going to go backwards, right? This is you plug in area, get perimeter. This is you plug in perimeter, get area. And that is it for number 7. Number 8, another log problem that we've seen multiple times throughout, our regular test quizzes in class and practice exams as well. So they kind of pop up all over the place. It's like a cylinder with a wedge cut out of it. Again, refer to the picture on the paper one, which will also be posted on Google Classroom as well if you don't have yours with you. Alex has been commissioned to create an art sculpture using 50 cylindrical bars of metal with a lengthways wedge cut out. Each piece will have length 3.8 meters and radius 12.6 centimeters, as illustrated in the following diagram, where O indicates the center of the circular cross-section. Right, again, refer to the picture, but do be mindful here, right, that the length is given in meters and that the radius is given in centimeters. So we're going to have to be converting at some point in the other. Don't just blindly use the numbers that they give us. All right. So the whole sculpture will use 7.5 meters cubed of metal. All right. And we know that he's using 50 cylindrical bars. All right. So 7.15 meters cubed, which is what they say used for the whole sculpture, divided by the 50 bars that he used for the sculpture, right, is equal to 0.143 meters cubed per bar. Right? Each bar has that volume. All right. It says to find the angle theta in degrees, defining the size of the wedge that each bar must have cut out of it. All right. So what we're doing here is we normally set up a proportion, right, when we know the angles, but here I'm doing 360 minus theta divided by 360, all right, of the volume of a bar, which is pi r squared h. So pi times r, and since our volume is in meters cubed, we want to change our centimeters to meters. So 12.6 centimeters is 0.126 meters, and that's pi r squared times h, which is 3.8. All right. So this part, and we know that this has to equal this 0.143. Whoops, forgot my one in there. That we found before. All right. So now I'm going to multiply both sides of the equation by this. Remember, if you do this first, you better use all the decimals that are given to you. Do not round this to 3 sig figs and then multiply by this. You will be off if you do. All right. I would just use this whole value here. All right. So we get 360 minus theta over 360 when I multiply both sides. Divide both sides by this, rather. All right, we will get 0.754503 8808. Again, we don't want to round here. All right. So now I'm going to multiply by 360, all right, and then subtract 360. So when I multiply this by 360, I get 271.6213971. And then when I subtract 360 from that, all right, we will get negative theta is equal to negative 88.3786. All right, so of course just multiply both sides by -1, and theta is equal to 88.4 degrees to 3 sig figs. So that's a tricky one if you don't kind of see how to set it up. Like, remember, we set up a proportion where we have, you know, the piece of the angle that we know over 360, right? So if you didn't see that right away, that can be kind of tricky. Of course, there are other ways to do it. That's just the fastest and most efficient. All right, and that was all for 8, just that one. All right, number 9. Astronomers classify the brightness of stars according to a scale of magnitudes. The difference in magnitude between two stars is defined by the formula, right? M1 minus M2 is equal to 2.5 times log base 10 of B2 over B1. When M1 and M2 are the magnitudes of the two stars, and B1 and B2 are the corresponding apparent brightnesses measured in watts per meter squared. The magnitude of a star is a unitless measure, and its value can be positive or negative. The star Sirius has a magnitude of negative 1.4 and an apparent brightness of 1.04 times 10 to the negative 7th watts per meter squared. Part A here. All right. The star Polaris has an apparent brightness of 4.62 times 10 to the negative 9th watts per meter squared. Calculate the magnitude of Polaris. All right. So we know that the magnitude of star Sirius is negative 1.4. All right, and we're looking for the magnitude of Polaris, which we don't know, and that's equal to 2.5 times log base 10. Of course, if you remember from pre-cal, log base 10 is just the common log. You don't really have to put the base there. All right, of the magnitude of Sirius is 1.04 times 10 to the negative 7th power over 4.62 times 10 to the negative 9th. 4.62 times 10 to the negative 9th. All right, again, I would plug this in via solver, all right, or at the worst, graph it and find the intersection, and you get negative 4.78. And again, magnitude has no units, so you don't need to worry about units. All right, that was A. And B. The sun has magnitude of negative 26.7. Calculate the apparent brightness of the sun. All right, again, I'm going to use the star Sirius because those numbers given to us are exact, right? So I would say negative 1.4 minus the magnitude of the sun is negative 26.7. All right, and that is equal to 2.5 log of B2 over B1, which we know is 1.04. times 10 to the negative 7th. Okay, so M1 and M2 are reversed here and here. So I feel like in A, I actually may have made a mistake. Yes. All right, so I made a mistake here. We need to flip these. Duh. All right, this is supposed to be B2 over B1 where I had them matched up, right? These two were together and these two were together, but they're supposed to be flipped. So I'll go ahead and redo this for you. All right, so I'm going to go to solver. All right, and my equation 1 will be negative 1.4 minus x. All right, and that's going to be equal to 2.5 times the log of 4.62 times 10 to the negative 7th, or negative 9th rather, sorry. All right, over 1.04 times 10 to the negative 7th. All right, we solve this thing. All right, 1.98 to 3 sig figs. All right, so this is 1.98 to 3 sig figs. Okay, so again, we can use a solver again for this if we want. All right, so of course, this is the magnitude of Polaris. All right, so here we'll be solving for B2, which is the relative brightness of the sun. All right, again, we can plug this into solver. So here, negative 1.4 minus, and here we will have negative 26.7. All right, and here we will have 2.5 log. And here I can just delete all of this stuff and put an X in there. And then I can solve. All right, 1370 to 3 sig figs. And that would be watts, whoops, not yet. Be watts per meters squared, of course, which is the same thing as watts over meters squared, right? Negative exponents just move things in the denominator. All right, so that's it for number 9. Number 10. All right. Jethro exercises every day, but he is terrible at making decisions. Therefore, each day he chooses one of his friends at random and rings them to ask what exercise he should do. Of Jethro's 18 friends, 13 of them are keen cyclists and will always tell him to go cycling. The other 5 are Tai Chi fanatics and will always tell him to do Tai Chi. On a given day, Jethro always does the exercises that his randomly chosen friends tell him to do. A. Find the probability that on any given day, Jethro will do Tai Chi. All right, so he's got 18 friends total. 5 of them love Tai Chi, so that's 5 out of 18. Pretty straightforward there. Then it says the month of June has 30 days. Find the probability that Jethro will do Tai Chi 10 times in June. All right. So exactly 10 times. We're doing the binomial distribution here. Binom PDF is an exact number. Remember, binom CDF is that number or fewer, all right, as far as percentages are concerned. All right, so we're going to do binomial PDF. There's 30 days in June, so 30 trials. The probability of doing Tai Chi is 5/18. All right. And we want to know the probability of him doing exactly 10. All right. So you plug this into your calculator. You go to second vars to get to distributions. Remember, this is also where we do all of our normal distribution stuff. All right. But we go up here to binomial PDF, since we're looking for an exact amount. There are 30 trials. The probability is 5/18. Right? And the value that we're looking for here is 10. So we paste that in our calculator. Bam, 0.123 to 3 sig figs. So that is the probability. All right. C. Find the probability that Jethro will go cycling at least 24 times in June. So this is 24 times or more. All right, so 24 or 25, 26, 27, 28, 29, or 30. All right, you could find the probability of each one of those individually and add them all together. All right, but remember, binomial CDF only does a number or less. All right, so we're actually going to find the probability. All right, and this will be CDF. All right, that he cycles 23 or fewer times. There's still 30 days in June. Now it's cycling though, so it's 13/18, right? Because 5 of his friends love Tai Chi, 13 love cycling. All right. And we're going to look for 23 or fewer. All right. So this is the probability that what they're asking doesn't happen. So if you just do 1 minus that, all right, then that will find the complement, which will look, this is the equivalent of saying 24 days or more. All right, so I'm going to plug that in here. We say 1 minus, all right, our binomial CDF this time. All right, still 30 trials. Now our probability is 13/18. All right, and we're looking for 23 or fewer. All right, so that is 0.232.